Hello everyone, my name is Sajid Parid. In this lecture, I will give a brief overview of various pre-processing steps involved in the production of WaPOR database components. The figure here shows the major components of the WaPOR data production workflow. It includes the acquisition of satellite and meteorological data, the pre-processing of the inputs, applying those intermediate inputs into the biophysical models to compute WaPOR database components such as ET and NPP, and finally the production and delivery mechanism. In the following slides, I'll be focusing more on the various pre-processing steps. The block diagram here further elaborates the data production workflow of WaPOR. The input data acquired from various sources are pre-processed to develop intermediates, which in turn becomes the input to various biophysical models. The biophysical models gives the final outputs of WaPOR database. The below part of this workflow diagram shows the various input data, the intermediate data sets, and the final WaPOR data components developed after applying the entire WaPOR data production workflow. In this slide, major pre-processing steps are listed. The input data is pre-processed to the correct format in terms of data format and the projection to be used directly in the processing chain of WaPOR data production workflow. Another major pre-processing step is to remove the clouds using cloud masks depending on the data source. Atmospheric correction of thermal data from VIRS to convert top of atmosphere brightness temperature to land surface temperature is carried out. The input data of different spatial resolutions are resampled to homogenize the resolution of the entire data set depending on the WaPOR data level. In the new version, methods such as thermal sharpening is introduced to remove the effects of coarse resolution land surface temperature. And finally, the smoothing of time series to remove the outliers and to fill the gaps due to clouds and cloud shadows are introduced. In terms of data format, WaPOR currently offers the products as cloud optimized geotiffs for entire Africa and Near East for level 1, or country-wise geotiffs for level 2, or for higher resolution level 3 for specific areas. These datasets are now offered in geographic latitude-longitude system. All input data required to produce the WaPOR data components are converted to the required resolution prior to the processing of the data components. In the new version 3, the data will be offered in MGRS tiling system, which is based on Universal Transverse Mercator or UTM grid system. Each tile will cover approximately 100 km by 100 km in area. For the optical satellite data, like data coming from Landsat, Sentinel-2, 3, VIRS, etc., clouds and cloud shadows are major obstacle. These satellite data are used extensively in WaPOR process chain to compute intermediate data components like NDVI, FAPAR, albedo, land surface temperature, etc. Hence, the accurate removal of cloud and cloud shadow pixels are very important. Cloud masks are used to remove these pixels. In WaPOR, cloud masks are produced using mainly two approaches. One is to use the quality layer associated with the data product, like the quality layer obtained from Landsat, MODIS products, etc. And for Sentinel-2 in version 3 of WaPOR, an artificial intelligence based kappa mask approach is used. The figure shown in this slide shows the true color composite of a Sentinel-2 data, the cloud mask obtained from kappa mask approach, and two other approaches called F-mask and Maja. Another major pre-processing step is atmospheric correction of thermal data, especially in version 3 of WaPOR. In the current version 2, this step is not required as existing land surface temperature products from different sensors like MODIS and Landsat are used. In version 3, to improve the spatial resolution of thermal data in all levels, WIRS data at 375 meter spatial resolution are used. But this data is available as top of atmosphere brightness temperature. Hence, it's important to do atmospheric correction to convert top of atmosphere brightness temperature to land surface temperature. This was done using a single channel algorithm by Muniz et al. The equations behind this algorithm are shown in this slide. In the version 3 of WaPOR, the thermal sharpening approach is introduced to produce high resolution LST from WIRS 375 meter thermal data. An approach called a data mining sharpener is implemented to create high resolution LST. This approach is implemented using open access library called PyDMS, published by European Space Agency and produced as part of a project called ET4FOW. In this approach, it builds regression trees between the low resolution brightness temperature data coming from WIRS and multiple features produced from high resolution Sentinel-2 data and high resolution elevation maps. These high resolution features are then used to predict LST and to obtain high resolution representation of the low resolution data, which in this case is WIRS brightness temperature data. The figure here shows the original WIRS image at 375 meter resolution converted to 100 meter and 10 meter using the PyDMS approach. As a comparison, a Landsat image obtained on the same day is also given at 100 meter resolution. One of the final steps in producing gap-free seamless time series of WaPOR data components is to apply smoothing to the time series of intermediate data components like NDVI. This process is done to remove outliers in time series and also to fill the gaps due to clouds and cloud shadows. The smoothing is applied mainly to the time series of NDVI followed by albedo and soil moisture. In the current version 2 of WaPOR, a weighted least square approach is applied to smooth the time series. In the version 3, a new approach is implemented, which is called Whittaker smoothing algorithm. The figure here shows the comparison between both approaches applied over a pixel in South Sudan and to the NDVI time series. Thank you for listening to my lecture on a brief overview on various pre-processing steps applied to WaPOR data components. Thank you.